All right, we've been looking at how to construct logical arguments. We've looked at statements and propositions. We've been looking at argument form, the concept of validity and invalidity. We've looked at simple statements and compound statements and symbols, replacing those simple and compound statements with their symbolic representation. And the final tool that I want to present to you is looking at operators. We want to look at how operators work to combine simple statements into compound statements. And these operators are going to be used in constructing arguments in your premises and your conclusion. I'm going to give you 4. There are others, but I'm going to give you 4 main operators that you can use to construct most arguments as you need to do that. Okay? So let's look at the first operator. This operator is called the negation. All right? It has a symbol, and you can find this on most keyboards. The tilde symbol is the operator for negation. It looks exactly like that. I don't know if you can see that. You'll have to zoom in on your screen there. And the negation, all the negation does is changes the truth value of the proposition that follows the negation symbol. All right. So the way we would symbolize a negation is using the tilde with the symbol for that proposition. All right, so let's say that A stands for Anne is home. The tilde in front of it means it is not the case that Anne is home. All right, that's how we would phrase this. That's all the negation does, is it flips the truth value. In our argument, we would write it this way symbolically, or we would write it out that way. We could also say not Anne, it is not the case that Anne is home, or not A is the other way that you would word this. Now, it's really important, the way that I have it structured here, the way I have it worded is quite important when you're constructing arguments in logic. We could say Anne is not home, correct? It would have exactly the same meaning, right? If Anne is home is true and we wanted to reverse that and say that it's not the case that Anne is home, or reverse the truth value, we could say that Anne is not home. But the way that I have it written here is to say it is not the case that Anne is home. Why did I write it that way? Well, we want to keep our simple sentence preserved. We want to keep Anne is home as a simple sentence the way that it is, without adding a new word to it. Anne is home is our simple statement. If you remember the lesson on simple statements earlier in the course, we want to keep that simple statement preserved, and we negate it by simply saying it is not the case that. Right? And that's going to be very important when we're constructing logical arguments, because if you start changing the sentences, if you start changing the simple sentences, you're going to lose track of what simple sentences you're working with. So always state it as not A, or it is not the case that, and then your simple sentence. Anne is home, Bob is home, the grass is green, whatever it is. Right? Try to keep your simple sentences preserved so the negation symbol will be structured exactly like that. All right? So that's the first symbol that we're going to be concerned with, the negation. The second one is called the conjunction symbol. And this is the and operator. This is the and operator. In logic, you can use an ampersand or a dot. In some older logic textbooks, you'll see an ampersand used. Modern textbooks tend to use the little dot symbol. If you're a computer programmer, again, you're going to see some of these symbols starting to show up in formal logic, ones that you already are used to using in computer programming. They operate exactly the same way, right? So in a conjunction, we have, I'll go to the bottom here, under the example, Anne is home, a simple statement, and we join it to another simple statement, Bob is home. We can symbolize that as A ampersand B, or A dot B, and we're simply joining two simple statements by using that and operator. This is called a conjunction. Anne is home and Bob is home is called a conjunction, a compound statement. And each simple sentence, each simple statement in the conjunction is called a conjunct. So I'm going to say Anne is home is a conjunct, Bob is home is a conjunct. In the conjunction, Anne is home and Bob is home. Right? So when you're referring to parts of a conjunction, you're going to refer to those parts as conjunct. When you're referring to the simple statements, each simple statement is a conjunct. By the way, you can have multiple simple statements conjoined using the symbols here, right? You could say Anne is home, and Bob is home, and Kyle is out, and Jan is swimming. Now you've got a conjunction with 4 conjuncts, and each will have its own truth value, and those will work together to give the entire conjunction a single truth value of true or false. All right, so that's the second operator that you're going to be using, conjunction. First one was negation. Now let's go to our third one. This is the disjunction operator. This is the OR operator in our toolkit. So the OR operator uses the V on your keyboard, or if you're writing it out, you just write it like a V. It's called a wedge in logic. And it's structured very similarly to the conjunction, only it's going to the way that the truth values work are going to be different. So here we have Ann is home or Bob is home. Each will have its own truth value. It creates a compound sentence, a compound statement joined by that conjunction. Joined by that disjunction symbol, and then the whole thing is called a disjunction. As in conjunction, each part of the disjunction has a specific name called the disjunct. So Ann is home, simple statement, that's a disjunct in the disjunction compound sentence, and Bob is home is also a disjunct, and we can refer to each of those parts as a disjunct when we're talking through the argument. Notice that we can combine disjunction and conjunction. We can say Ann is home or Bob is home and Kyle is swimming. Right now we've combined the conjunction with the disjunction. We can also throw a negation in there if we wanted to. We could say Ann is home or Bob is home and Kyle is swimming, but it is not the case that Susie is riding her bike. Right? So we can bring all of these operators together to create very more complex compound statements, and each of these has its truth value. Now I want to just take a moment to look at how truth value works in each of these scenarios. So let's look at conjunction again. Suppose I said Ann is home is true and Bob is home is true. What is the truth value, do you think, of the entire compound statement, the conjunction as a whole? Well, if both conjuncts are true, doesn't it seem like the entire conjunction would be true? If we're going to say Ann is home and Bob is home, and Ann is home is true and Bob is home is true, the whole thing would be true, right? Because both simple statements are true. Now let's change Bob is home to false. Ann is home and Bob is home, but Bob is home is actually false. What do you think the truth value of the entire conjunction would be? Intuitively, doesn't it seem like it would be false? Because now we're saying that these statements, since one of them is false, the whole thing has to be false. So in that condition, the entire conjunction would have the truth value of false because one of the conjuncts is false. We can do the same thing with disjunction. Right? Ann is home or Bob is home. Let's suppose both are true. It would seem that the entire disjunction is true. Now let's change Bob is home to false. Ann is home or Bob is home. What do your intuitions tell you? Actually, in a disjunction, if either disjunct is true, then the entire disjunction is true still. Right? So in conjunction, it made the whole conjunction false. In disjunction, we can have one of the disjuncts as false, and still the whole disjunction is true. Right? Because think about that intuitively. Ann is home or Bob is home is false, Ann is home is true, the disjunction is still true. Now, if we change both to false, Ann is home is false and Bob is home is false, then the whole disjunction becomes false, right? That we have an intuition that that's a false statement. All right, so that's how truth value relates to our symbols and our operators in constructing logical arguments. So we have negation, we have conjunction, we have disjunction. I'm going to give you one more called the conditional. This is a very important construct in logic, and you'll use it pretty heavily when you're creating arguments. Under the conditional, you'll use the arrow or the horseshoe. You can use either. Again, modern textbooks generally go with the arrow symbol for the conditional. They're called horseshoe and arrow, obviously, under the symbol name. The construction is down here at the bottom if you look under the example. If Ann is home, then Bob is home. That's how you write a conditional. The way that it's symbolized is you put the first simple sentence before the operator. So here we have A horseshoe B or A arrow B. A is the first simple statement, B is the second, and the be follows what would be essentially the then statement if we were writing it out in English. Okay? Like the conditional and the disjunction, like the conjunction and the disjunction, each part of the conditional has a specific label, a name that logicians have given it. Okay? The part that follows the if, or the part that comes before the symbol, is called the antecedent. The antecedent. So that would be the a, or Anne is home in our example here. That's called the antecedent. The simple statement that follows the horseshoe, follows the symbol, or follows the then in English is called the consequent, right? The antecedent and the consequent, right? So here, Bob is home then functions as the consequent, Anne is home functions as the antecedent, and it's always written that way, okay? Now notice too that the simple statement does not include the if. The if is a part of the symbol itself, the operator itself. So if I were to ask you what is the antecedent of the example down here below, you would say the antecedent is Anne is home, not if Anne is home. You leave the if and the then off the simple statements. The consequent of this statement here, this conditional, is Bob is home, not then Bob is home. All right, the if and the then are a part of the operator. They don't get included in the simple statements. All right. Now again, you can add other operators here. You can say if Anne is home, then Bob is home and Kyle is swimming. All right. You can group those together to use the symbols and the operators in conjunction with each other. All right, so those are 4 operators. You can use these operators to build compound statements that then you can use in your logical arguments. As we get further into the course, you're going to see how these operators are used to build arguments.